In this video, we are going to look at the proof of the theorem that if a series converges absolutely, the series itself converges. Now, to get started on this particular proof, we are going to need some tools. So I kind of want to look at the tools that we need. The first thing is that we need the definition. When we say that this thing converges absolutely, what we actually mean by that is that, so that phrase means that if we throw absolute values around the terms, this series converges. And it is important to realize that this is a positive term series. The second thing that we need lined up is the idea that for any real number, x is always going to be less than or equal to its absolute value. So in particular, for each of the AKs, we know that AK is less than or equal to the absolute value of AK. The third thing that we're going to need in our list of tools is a couple of things about series themselves. One is that if I take a positive term series, and I'm going to call this BK, so if BK is a positive term series, and this positive term series converges, so, and this series converges, then so does the series C times BK. In fact, C times BK converges to C times the series of the BKs. So this guy converges. And the fourth tool that we need before we can start in on our proof is that if I have two non-negative term series, so if BK and the series of CKs are both non-negative term series, and both of them converge, then it turns out that any sum of them, so if I look at the BKs plus CK, and the series formed by looking at the differences of their terms, these two things both converge. And basically the idea here is if the series of BKs goes to L1 and the series of CKs goes to L2, then the series of BKs plus CKs winds up going to L1 plus L2, and the series of BK minus CKs, that series converges to L1 minus L2. In other words, if I'm looking at a sum, it looks like I can split the thing into a series of BKs plus a series of CKs, and if I'm looking at a difference, then I can split the series into a series of BKs minus the series of CKs. But these two facts, do require knowing that the BK series and the CK series both converge. So those are our tools. Now what I'm going to do is we're going to look at what does it mean when we have the series AK converges absolutely, and we want to try and show that the series of AK itself converges. So let's go to a new sheet. Our hypothesis is that we have a series that converges absolutely. So what that means is that we know that the series of absolute values converges. Because that's just the definition of absolute convergence. Now we're actually going to introduce a weird series in the middle that's going to get us where we need to go. And so what I want to do now is I'm going to actually let BK be AK plus the absolute value of AK. And there are several things that I know about BK. The first thing is that BK is always going to be bigger than or equal to 0 because at worst, AK and the absolute value of AK are additive inverses of each other. And on the other hand, if AK happens to be positive, then this sum up here is actually equal to 2 times the absolute value of AK. So both of the inequalities in this statement are because the absolute value of AK is less than or equal to, well, AK itself is less than or equal to the absolute value of AK, and AK is either equal to the absolute value of AK or minus AK is equal to the absolute value of AK. So this is a basic fact. Now what that means is that the series of BKs is going to be less than or equal to the series of 2 times the absolute value of AK, and this guy converges. In fact, basically, this guy is equal to 2 times the series of absolute values, and this converges by the hypothesis. So what I want to notice is that what we've got is that the series of BKs is less than or equal to 2 times the absolute value of AK. This is a convergent series. It's a convergent positive term series. And the BKs are a non-negative series. And that's the setup for the comparison test. So what this tells me is that the series of BKs converges by the comparison test. Now remember that BK itself is equal to AK plus the absolute value of AK. So let's do a recall there. So what that means is that we now know that the series of AK plus absolute value of AK, that series converges by the comparison test. Well, what does that by mean? Well, let's consider that fact. So what I'm going to do is I'm going to recall that we just got done proving that the series of AK plus the absolute value of AK, that guy converges by the comparison test. Well, what I now want to notice is this. We also know, of course, that the series of absolute values of AK converges. That's our hypothesis. And what this says is that if I look at a series that has terms, the first series minus the second series term. So I'm looking at a series that has this term minus this term. Here, let me actually introduce a set of new symbols to make this just a little bit clearer. These will come back in just a minute, but I want to make it real clear. We are going to let CK equal these terms, AK plus absolute value of AK, minus those terms. And then what I want to notice is that what we've got is that the series of CKs has to converge because this series converges and this series converges. In fact, what we actually know is that the series of CKs is going to converge to whatever this series converges to minus whatever this series converges to. So we know that the series of CKs converges. But now look at this. Each CK, which is AK plus the absolute value of AK minus the absolute value of AK, can be simplified to be AK plus that absolute value minus that absolute value. And of course, this mess winds up adding together to be a 0, so CK is nothing more than AK. And so the series of CKs is exactly the series of AKs. So since we already know the series of CKs converges, that means we must have the series of AKs converges. And so what that means is that we have indeed proved, so we have now proved that if a particular series converges absolutely, then the series itself converges. And that's what we had set out to do in this particular video.